Good evening. I'm Anitha, Assistant Professor in the Department of Artificial Intelligence and Data Science. Let me see about the clustering analysis. First, what is clustering analysis? Clustering analysis is often used as a pre-processing steps for various machine learning algorithms. Classification algorithm run cluster analysis on an extensive data set to filter out data that belongs to obvious groups. Advanced data classification techniques can then be used on a reduced non-obvious data points. Next, cluster analysis is a process to find similar group of objects in order to form clusters. It is an unsupervised machine learning based algorithm that acts as unlabeled data. A group of data point would comprises together to form a cluster in which all the groups would belong to the same group. The data divided into different groups by combining similar objects into a group. This group is nothing but a clusters. A cluster is nothing but a collection of similar data which is grouped together. For example, consider a data sets of vehicle given in which it contains information different vehicles like car, buses, bicycles, etc. As it is unsupervised learning, there are no class labels like car, bikes, etc. for all the vehicles. All the data is combined and it is not in the structured manner. Next is properties of clusterings. Clustering scalability. Nowadays, there is a vast amount of data and should be dealing with huge databases. In order to handle extensive databases, the clusters algorithm should be scalable. Data should be scalable. If it is not scalable, then we can't get the appropriate result, which would lead to wrong results. High dimensionality. The algorithm should be able to handle high dimensional space along with the data of small size. Algorithm usability with multiple data kinds. Different kinds of data can be used with algorithms of clusterings. It should be capable of dealing with different types of data like discrete, categorical and interval based data, binary data, etc. Dealing with unstructured data, there would be some databases that contain missing values or noisy or erroneous data. If the errors are sensitive to such data that and then it may lead to poor quality clusters. So it should be able to handle unstructured data and given some structure to the data by organizing it into groups of similar data objects. This makes the job of data expert easier in order to process the data and discover data patterns. Interpretability, the cluster's outcomes should be interpretable, comprehensible and usable. The interpretability reflects how easy the data is understood. Next, applications of cluster analysis. It wide range used in image processing, data analysis and pattern recognition. It helps marketers to find the distinct groups in their custom based, and they can characterize their custom group by using purchase patterns. It can be used in the field of biology by deriving animals and plants taxonomies and identifying genes with the some capabilities. It also helps in information discovery by classifying documents on the web. Requirements of clustering and data mining is scalability and the ability to deal with different kinds of attributes, and discovery of clusters with attribute shape, high dimensionality, ability to deal with noisy data, interpretability. These are some of the requirements of clustering and data in data mining. Next, some advantages of clustering analysis is to identify patterns and relationship within a data set that not be immediately obvious. It can be used for exploratory data analysis and can help with feature selection. It can be used to reduce the dimensionality of data. It can be used for anomaly detections and outlier identification. It can be used for market segmentations and customer profiling. And some of the discovery of clusters with attribute shape. The clustering algorithm should be capable of detect clusters of arbitrary shapes. They should not be bound to only distance measures, and this tend to find spherical cluster of small sizes. High dimensionality, the cluster algorithm that should not be able to handle low dimensional data, but also the high dimensional spaces. It can be sensitive to the choice of initial conditions of the number of clusters, and it can be sensitive to presence of noise or outliers in the data. It is difficult to interpret the results of analysis if the clusters are not well defined. It can be computationally expensive for large data sets. The results of the analysis can be affected by the choice of cluster algorithm used. It is important to note that the success of clusters analysis depends on the data. The goal is the analysis and the ability of the analysis to interpret the results. Thank you.